So good afternoon to one and all. Today we are going to discuss the practical of measurement of low resistance by using Kelvin double bridge. Okay. Already we have discussed the measure for the high resistance measurement. For the medium resistance measurement, we have discussed about the Wilson bridge. In the last week, we have discussed the Wilson bridge. So now we'll go for the measurement of low resistance by using a Kelvin double bridge. This Kelvin double bridge circuit we are going to use for the measurement of 1 ohm to the some 10 micro ohm, up to the micro ohm also. In the 10 micro ohm we are going to measure this one. So the title of the experiment is measurement of low resistance by using Kelvin double bridge. Okay, so based on this title we can describe, can tell the aim of the experiment is to measure of low resistance by using Kelvin double bridge. The Kelvin has derived this bridge or circuit which is having actually in the Wilson we have only one bridge it was connected. Here instead of single bridge he has formed the double bridge circuit he has formed. For that reason Kelvin has derived the name came here Kelvin double bridge. So this Kelvin double bridge we are going to use for the measurement of low resistance. That one we have considered here. So the equipments required to perform the practical is the trainer kit is required for the Kelvin double bridge trainer kit, and kit comprises DC supply. So Kelvin double bridge is a AC bridge or DC circuit it is. Whatever the resistance measurement is there here, Wilson bridge, Kelvin double bridge, these all are the DC bridges. These are not applicable for the AC bridge. These are the DC bridges. The AC bridges are sharing bridge, Maxwell bridges. When you will start the third unit, you will understand that one here. So to give the supply of 10 volt, the DC supply is required. DC supply kit is required 0 to 10 volt. 1 ampere current kit is nothing but so one quantity here now. So to measure this voltage we want one digital multimeter. So one digital multimeter I have added here now. So to do the connection of this as per the circuit diagram, so connecting patch cords are required. Those patch cords some I have written here. So this is the circuit diagram of the Kelvin double. Yes,
स्क्रीन चेंज झाली नाही.
प्रॉब्लम क्या हो रहा है आप लोगों को? सो शायद रिकॉर्डिंग करने के बाद नहीं होता अभी. सर्किट डायग्राम दिख रहे?
नो सर.
सर्किट डायग्राम इज नॉट विजिबल?
नॉट सर.
No, sir.
Now what is visible?
Yes, aim apparatus.
Okay. Instead of using that, I have saved complete screen. Okay. These are the equipments required to perform the practical of low resistance measurement by using Kelvin double bridge. We'll go for the circuit diagram. Is it visible? Circuit diagram is visible?
Yes, sir.
Okay. See here, in the previously, what we have used over for the Wilson bridge, we have used only so for the Wilson bridge, we have used, this is not marking. We have used one bridge circuit like this we have used. Yes, in between these 2 points, I have connected a galvanometer. It is one bridge only. One bridge only. So whatever this line is there, this is one bridge we are going to call here up to this continuation path here. But in between this here, one more, two more particles, two more extra resistances we have used at this condition here, in this condition. So this is one bridge, this is another bridge here now. This will act as another bridge. This is completely one bridge. So two bridges are there. For that reason, the name came double bridge here now. The name came the double bridge here. This is the circuit diagram. So don't get confused for the part of here I have used R1, R2. In the previous case, I have used P, Q, R, S. Okay. Nothing to worry about the P, Q, R, S or R1, R2, R3. Whatever it may be, here R1 connect है, इधर R1 connect कर सकते हैं. That is not a necessary. Nothing to worry about that one. R1 is connected to here, R2 is connected to misplaced and all the things. But based on this, the formula you have to remember that is very important. Formula we have to very important. So P equal to QR by S last time, or S equal to QR by P, like that you have derived here. No, P Q R S we have used like that in the last time. So comparing that only in our kit, experimental kit, we are using R1, R2, R3, RX. RX is the unknown resistance we are going to use here. So if you got the formula for this one or this one or this one, we can derive the equation for this also. Nothing to worry about that one. So inside here now, from this point to this point, we are doing a connecting wire here. But previously, directly this resistance is connecting to here. This one is connecting to the here. One more branch here now. But to measure the resistance for the low value, we are forming one more bridge they have formed here now. So these two are the ratio bridge equations, ratio arms we are going to call that one here now. Here R1, R2 we are using here, R1, R2 we are using. In other circuit, we may use this one as PQ also. Just a minute, I can write this one as, this is P, this is Q I can use, and this one is small p and small q I can use. Some other circuits they have used it like that. This is R and this one is yes, R and yes. Like that, we can use that one here. So PS equal to QR. The formula you have derived already. P into S equal to Q into R. Have you derived or not? The Whitson bridge, we have discussed that this is the advanced form of the Whitson bridge only. Whitson bridge, only one bridge we have used here. Double bridge here we are using. This is the advanced form of Whitson bridge only. So the formula previously we have discussed, PS equal to QR. PS equal to QR. Same thing we are going to get here also. But here two more arms are there. This one more bridge we have used here now. We have used here now. These are the ratio arms we are going to call. Ratio arm means P by this one, Q equal to P by Q equal to this small p by Q also we are going to call here. Small p by Q. Whenever these two ratios are equal, on that condition, we can say that the bridge is balanced here. In that condition, the bridge is balanced. We are going to say that one. The theory part of this one, we have to derive this. We have to prove the derivation of this one here. So R1 equal to P, R2 equal to Q, R3 equal to R, and R4 equal to X, Rx equal to yes, we can call that one here now. So in the textbook I have used a different here, R1, R2 is there. Don't get confused of that one here now. So some theory part, I will go for the class PPTs. I will explain that one. Instead of taking this one, you will understand more on that one. See here, the Kelvin double bridge. Is it visible? Kelvin double bridge slide.
Yes, sir.
Kelvin double bridge is a modification of Whitson's bridge and is used to measure values of resistances below 1 ohm. So low resistance means below 1 ohm only we are going to use. This Kelvin double bridge is a modification of Whitson bridge. So Kelvin double bridge is used for the measurement of low resistance. Low resistance, it will vary in the range of 1 ohm to the 10 micro ohm. 1 ohm to the 10 micro ohm, it is going to vary. 10 into 10 to the power of minus 6. It is nothing but 0.00001 ohm. So less than 1 ohm only it is. 10 micro ohm is nothing but less than 1 ohm only, na? Micro means. Is it audible?
Yes, sir.
So less than 1 ohm, we are going to measure here. So the accuracy we are going to accept for the plus or minus 0.5 to the 0.05 to the 0.2. This is the accepted accuracy or error, we can call that one here. Now, the accuracy of the measurement of low resistance in a Kelvin double bridge is of order of 0.05 to the 0.2, plus or minus, both are acceptable. We are going to call that one here. This is the bridge we are going to consider. See here, in the place of the circuit practical, I have used R1, R2. Here small pq as it is. So R, yes, like that we have used. But there R1, R2, R3, R4, like that we are going to use. Here in the textbook they have mentioned like this only. If you are going to refer the textbook, it should not be confused over there. In the place of P you substitute R, Q R2 substitute करो, R का place में R3 करो, S का place में R4 करो, नहीं तो RX or whatever it may be unknown also we can put over there. Unknown resistance also we can put over there. Just a minute. Okay, so this is the idea, incorporate the idea of the second set of ratio arms, hence the name came double bridge. As I explained that the double bridge and the use of this one is used for the measurement of low resistance here now. So this is a figure shows that here now the first ratio arms are nothing but P and Q here now. This P and Q is the first ratio arm. Second ratio arms are the P and Q, these two small P and Q here now. Capital P and Q are the first ratio arms. Second ratio arms are the small P and Q are here now. Here, this is the standard resistance or unknown resistance, we are going to call that one here now. Or in this one R and S, one is standard resistance, another one is the, we can call that one as unknown resistance here now. So yes, we are going to call as unknown resistance, R we are going to call as the standard resistance. Any one we can use that one, we can call that one. We are going to derive the formula for that only here now. So here I will consider R as the unknown resistance here now. R as the unknown resistance. So yes is the standard resistance. We have to derive the equation here now. For the same equation, same diagram, we have to derive the equation here. We have to derive the equation here. See here, this is the circuit diagram. So the ratio P by Q is made equal to the P by Q here now. Small P by Q equal to capital P by Q. That is under balance condition. We are going to call that one here. Under balance condition, there is no current through the galvanometer. In this galvanometer, there is no current flow here, means the bridge is said to be balanced, which means that the voltage drop between A and D is this one here now. A and D is equal to the voltage drop between A and C is nothing but EMC. A and C, where is C here? This one here, AMC here. So voltage drop across this one equal to voltage drop across this one. If it is there, we can say that the bridge is balanced here. So based on that, we have to derive the equation. This equation we have to derive here. So the EAD, this is nothing but EAD only. EAD equal to EAD equal to, we can call that one EAC. EAC, both I told both are equal only. EAC into P divided by P plus Q. The ratio arms we have to add here now. So EAD equal to P. This EAD, whatever the resistance is there, P is there. P divided by the connected first ratio arms are there, P plus Q into what is the EAC we have to add here. EAC we have to add here now. EAD equal to P plus P divided by P plus Q into EAC. So next we have to derive EAC, not EAC, sorry, EAB we have to derive here now. EAB we have to derive here now. EAB equal to the current is flowing here now. V equal to IR, we know that one. I will multiply here. I will keep as it is here now. See here, the circuit is, it looks like the circuit is looks like, I will draw the circuit also. See here, you start from A point. A point se start karo. A point where R is there. Next M point is there. M point se two paths we are going to get here now. So this is small p, next small q, next this one is continuous R is there, it will close here. Next the S is there here. Yes is there. So this is the A, this is the B. This part I am asking here now. Either se chalu ho gaye, some this one path here now and another path is like this here. It looks like this only because in the galvanometer there is no current, balanced condition we have called this one. Yes, it looks like this only. This is R, this is small p, this is small q, and this is small r, and this is called S here. This is called S. Is it clear? This one, this equation I am telling here now. EAB, voltage drop across A and B. Is it audible? Is it audible?
Sir.
Okay. So EAB, from A to B, we have two potential drop. So current I will consider as I here now. Current I will consider as I here now. I, okay, I will keep as it is outside. Here R is there. I will write R. All are in series circuit. I told that one R. Plus here two paths we will get over there. This complete, these two are in series. P and Q are in series. Yes?
Yes, sir.
So this one, A and B, P plus Q is A, R equal to B. AB divided by A plus B, we can write like this.
Yes, sir.
So P plus Q into B is R. I will write here now. P plus Q into R divided by P plus Q plus this one only. P plus Q plus R here. Plus S is, we can write plus S. So I will write here now. So the equation of EAB equal to R plus S plus P plus Q whole bracket whole into R divided by P plus Q plus R here. So EAD we have calculated, EAB we have calculated. Next I told that one EAD equal to EAMC. EAMC they have called here now. So EAMC, to calculate that one here, this one, this part we have to calculate here. EAMC here. So A to M, it is there, R is there. A to M, R is there.
Yes, sir.
So R I will write here now. A to A, R I will write here now. So this one here, M to C, same like A to D we have calculated here now. P by Q into this one. So this small p divided by P plus Q, the ratio arm we are going to apply here now. So that one we have applied here now. P divided by P plus Q here. Next, this one. Here to here we have calculated, but is there any point here connection is there? No. The same current will flow to the up to B only. Up to N it is going to be here. So these two are in series. The P plus Q are in parallel with R. P plus Q. These two P and Q are in series, and the total P plus Q is in parallel with R. Yes or no?
Yes, sir.
The same we have to apply P plus Q into R divided by P plus Q plus R here now. So applying this equation, here also P plus Q is there. Here also P plus Q is there. Will get cancelled. Multiplication is there here. P plus Q gets cancelled. You can open bracket, you can put here now, like that. Is it correct or not?
Yes,
You can
sir.
cancel this one. Yes. So after cancellation, what is the term left here now? What is the term left here now? R plus small pr divided by P plus Q plus R. This is the EAMC here now. EAMC, the equation we have done here. See here, under balanced condition, the previous only I told that one. Under balanced condition, EAD is equal to the EAMC. EAD is this one here now. So EAMC is this one here now. Equating these two equation, what we will do? P plus Q into this equation EAB I R plus S plus PQ plus R. This is EAD here now, equal to I into this equation we can write here now. So directly they have not written, same as it is they have considered here now. So I will cancel here only. I will cancel here only P plus Q, and this P plus Q we can get cancelled here now. So, and I gets cancelled. Here also I is there, here also I is there. This I and this I will get cancelled here. Yes, I get cancelled. So we'll go for this after deriving this equation, we will get directly this equation we are going to get. Can you solve? How do we get this equation? Any one of you? Will you solve, or I have to show? Okay, I will only derive that one. So to derive that, we have to take next slide, one blank slide. I will take that one. Here I will take that one. It is visible. Is it visible? Is it visible or not?
Yes, sir.
Yes, sir.
So EAD equal to P divided by capital P plus Q into I. What happened to this one? Into I. Open bracket. I will take R plus S plus this one small p plus Q R divided by P plus Q plus R here. Is it correct? This is EAB equal to EAMC equal to what we have derived. Last equation directly I will write I equal to R plus PR divided by P plus Q plus R here. This equation I will write here. So from this equation EAB and EAD, I will remove this format here. Now both are equating here. By equating both these two equations, we have to derive the values for the resistance. We have to derive here. We have to derive the values for the resistance here now. And I will take the chocolate color now. No need to make the partition also. So can I send this part into RHS side? Here I will get cancel. I get cancelled here now. I both are multiplication factor only, both are multiplying over there. Yes. Reply. आवाज आ रहा है क्या नहीं? Okay. Next, this complete term of P divided by P plus Q, I will send into RHS side. What it will become? The LHS side, what is the term left? This term I will write here now. See here. This is R plus S plus R plus S P plus Q, small p and capital Q, remember very carefully. P plus Q plus R. This is one side, LHS side. In the RHS side, R plus PR divided by P plus Q plus R. Pen and paper. P plus Q plus R whole into I will send this part into RHS side. It will become what here now? It will become P plus Q divided by P. Numerator to denominator, denominator to numerator हो जाएगा वो. Yes or no? 1 by 2 or 2 by 3 I will send into RHS side. It will become 3 by 2.
Yes, sir.
So that is called P plus Q divided by P we have to write here. Divided by P we have to write. Okay. Next what we will do, we will multiply this P plus Q into a here. So P plus Q divided by P into R हो गए. This complete form. Yes or no? This whole circuit you multiply, split into one A plus B into C. I say,
Yes,
na,
sir.
this is A plus B plus C. Try to give the reply. Otherwise, directly I will put the option. Directly I will show the answer and I will move to the next point. If you want to understand, I will continue. Otherwise, I'll skip all these things. Remember, PR plus P plus Q plus R into P plus Q divided by P. We keep as it is here. So here also R term is there, capital R. Here also capital R term is there. What you do, you complete term, you send into RHS side. You complete term, you send into RHS side. It will become minus now here.
Yes, sir.
Okay. So I will take R outside, means here 1 is left here now. 1 in the place of R. 1. When I will send into minus, it is nothing but it will become minus P minus Q divided by P here.
R.
Not R here, this one. What is this? This is P only. P only, na? P plus Q divided by into P.
Yes, yes, sir.
Okay. So that one, you close it now. Plus yes, we write as it is. Otherwise, what you do, this yes and all the things you send into RHS side. This yes, I will send into RHS side. What will become? It will become minus. Yes.
Yes, sir.
Otherwise, I have sent into this one into LHS side. So RHS term, whatever is there, you write as it is here now. PR divided by P plus Q plus R into P plus Q divided by P. I have written as it is. When I with the S is sent into RHS side, it will become minus S. Yes. So minus P plus Q. I will split this term also. You split into this term. P into R and Q into R we can write here. PR plus QR we can write directly.
Yes, sir.
So PR plus QR divided by P plus Q plus R. Yes. Can write like this.
PR minus QR in Anna.
No, this complete term we have kept here only. Now when we are splitting this one means again it will minus.
Okay, sir.
This is like this. Okay. Next, here, what is the LCM is P here now. This equation we can write like this. P minus Q divided by P.
Yes, sir.
We can write like this. So this plus P and minus P gets cancelled. Yes.
Yes, sir.
Plus
Yes,
P
sir.
and minus P get cancelled. Here PR, this term, this complete term, can I write like this here? I will show you peoples. I will write in the, okay, leave that one here only, downside I will write. Okay. Still so much place is there. So this is PR, P plus Q plus R into P plus Q divided by P minus S minus, now I will split this term into minus PR, P plus Q plus R minus QR, P plus Q plus R. You can write like this.
Yes, sir.
Yes. So here plus PR term is there. Here, sorry, minus PR plus PR term is there. We can take this term as common. We can take outside.
Yes, sir.
Okay. I will write this PR divided by P plus Q plus R. I will take outside here now. I will take outside here. P plus Q plus divided by P. What is this term? Complete minus 1. I can write like this. Minus S minus QR divided by P plus Q plus R. Is it correct? You
Yes,
can write like this. Okay. I will take the another color. Next. So the RHS side, we can LHS side, I can write R, sorry, minus Q, na? R minus Q divided by P, minus Q divided by P equal to PR divided by P plus Q plus R. This term we can write here. See here, P plus Q, this LCM is P here now, into minus P. P plus Q minus P divided by P. So here also Q by P will get only term.
Yes, sir.
Yes,
So
sir.
directly I will write here. Directly I will write Q by P. I will write here now. Q by P. I will write minus S minus QR divided by P plus Q plus R here. Q plus, just a minute, I will shift the camera outside. P plus Q plus R here. Q plus P plus R. Next, what we have to do here, this Q by P is there. We have to, I will derive the only unknown resistance. I will consider R only here. I will keep this R only. This complete term, when I will send into RHS side, what will become? It is minus P by Q multiplication factor will be occurred here. To all multiplication factor हो जाएगा ये सबको.
Yes, sir.
So directly I will write here only. Listen carefully. PR, I will keep this one as it is. PR, P plus Q plus R. This one, Q by P is there, into minus P by Q. You can write like this. इसको
Yes, sir.
multiply. Next, minus and this minus, it will become plus. ये टर्म को मल्टीप्लाई करने का, ये टर्म को मल्टीप्लाई करने का, ये टर्म को मल्टीप्लाई करना है, दिस P by Q को. Yes.
Yes,
Minus
sir.
P by Q. So here also minus is there, here also minus is there. Minus into minus plus. I will write
Plus.
yes as it is. P by Q directly I will write. QR P plus Q plus R into P by Q here now, into P by Q. So this PP get cancelled, QQ get cancelled here now. So the minus term I will write here. Yes.
Yes, sir.
So we can write like this. This one P by Q into S. This term I will write here now first, plus QR divided by P plus Q plus R into P by Q minus PR divided by P plus Q plus R here. This one. Can I write like this?
Yes, sir.
Okay. Next, I will keep this one as P plus Q into S. I will keep as it is outside only. Plus, what I will do, I will take the outside common terms. I will take outside here now. I will take outside of this one here. QR, this QR is there. I will take QR divided by P plus Q plus R I will take outside here. ये टर्म, ये दोनों का बीच में मैंने ये टर्म आउटसाइड ली है. द फर्स्ट टर्म ये क्या बच गया इधर, व्हाट द लेफ्ट टर्म इज ओनली P by Q is left here now. When I will write this one as outside here now, common I have taken. Minus sign you write this one. The new denominator P plus Q plus R is there. P plus Q plus R we have taken outside already. Yes?
Yes, sir.
Here R is there. R we have taken outside. What is the left term here now? Small p is left. Small p I will write here. But here Q we have taken, but there is no Q here now. So we can make this one as divided by Q.
Yes, sir.
We can make this one as divided by Q. Yes, but we know that for the balanced condition, P by Q equal to P by Q. Yes, this equation we know already. So P by Q minus P by Q, this equal to 0 ho gaye. This complete term will become 0. 0 into anything, it will become 0 only. What is the term left here now? R equal to P by Q into S here. Or S equal to QR divided by P also. Whatever it may be, we can write like this. Yes?
Yes, sir.
What is the previous Wilson bridge equation? This one only we have proved. R equal to PS by Q only. Or S equal to QR by P. Like that only we have derived, na? Yes or no? So similarly, the equation we are going to derive here now. So the formula equation is clear. The derivation is clear. The same thing it will comes into your third unit. On that time, I will not repeat this part. For that reason, we have taken the derivation now here. When you will go for the practical, I will clear that one. If anybody want to take the screenshot, means you can take this one. Where we have done, I will keep this one in the problem. Here only. If anybody want to take the screenshot, means you can take it now only. Okay. So from this, I will clear all the things here now. So the come to the practical orientation. The equation for the this derivation here now. So this one we have considered as yes here now. This one R we have considered. R equation we got means we can easily we can write the RS formula also here now. So R1, R2, R3, R4, RRX is the unknown resistance we have used here now. So the equation for the unknown resistance is this is downside. दिख रही है? Complete downside, is it visible? No. See here. This one Rx equal to what is that? Is it R2 by R1 into R3? So R2 R3 divided by R1, you can write like this. Rx R4 equal to previous equation. Previously in the Wilson bridge you have considered this same equation. Rx equal to or R4 equal to R2 R3 divided by R1 here now. Is it correct?
Yes, sir.
So same equation we are going to use to perform the practical here. Same equation we are going to use to perform the practical here now. So this much theory, to explain this much theory part, I went to the whole derivation I have derived for you people. So for the balanced condition, the formula for the R2, R3 is a known value. So standard value we are going to consider that one. R2 is known value, R1 also known value, R3 also known value. We have to find in a kit, we have to find the Rx value by using this formula R2, R3 divided by R1 here now. So the procedure for this experiment is, first of all, switch on the trainer. We have to switch on that one. connect the circuit diagram. As per the circuit diagram, we have to do the connection. Next, we have to apply some voltage 0 to 10 volts or 15 volts here now. And we have to select one in a kit. They have provided of 2.1. Of 2.1, they have provided the resistance over there. Okay, up to 1 ohm they have provided over there. We can choose 0 0.1, 0 0.2, 0 0.3, 5, 6, 7. So 0 0.9 or 1 ohm also we can choose over there. So based on that, then what we have to do, with the help of the other variable resistance R1 and R3, we have to adjust the galvanometer should be 0. When the galvanometer is 0, we have to note down the value of R1, R2, R3 and calculate the unknown resistance. In that calculated value, we have to write in this table. R1 by R2 ratio arms, we are going to tell that one. This ratio arms is not necessary actually. Standard R3 value we have to measure here, and Rx measured and calculated value. So actual value of Rx and measured and calculated, we can write this one here. Measured value and calculated. Actual kitna ho gaye and measured is how much. Means measured is nothing but calculated. Actual value in the kit, how much is that? We have to choose that. Is it clear? We'll do the practical now. Can I go to the kit?
Yes, sir.
Just a minute. To go to the kit, someone is waiting in the waiting room. Just a minute. हाँ सर बोले. Any one of you take the observation table as like this. You take down. Hello. Have you taken the observation table? I'll stop the sharing now. Is it audible?
Yes, sir.
Okay. Just wait a minute. हाँ उनको मैसेज किया तो यूजर नेम पासवर्ड मिलने वाला है, बोल दो उनको. Is it audible?
Yes, sir.
Okay. So this is the kit of your practical. Actually, I have done the connection as per the circuit diagram. Otherwise, I'll remove the connection also. I will remove that one and I will explain that. Here, this one is the bridge circuit. This is the first arm ratio R1 and R2 here. R2 value, there are three values they have given. That is, one is 100 ohm, second one is 250 ohm, third one is 330 ohm. Out of these three, we have to choose any one values here. Any one values we have to choose and we have to connect here now. I will take 250 now. I will take 250 and I will connect to this dotted line indicates in the last lab I have told. It is you have to do the connection here. I'll take 250 now. Okay. Next, here DC supply point, DC power supply they have given here. This is the DC power supply, and in the circuit they have provided 2 points for the power supply. So positive to positive, here positive to positive, negative to negative, we have to do the connection. I have done this one. And the galvanometer should have to connect in between these 2 points here now. In between these 2 points. So I will connect. Just a minute. I have to check which cable we have to connect the positive terminal. So the positive terminal I will connect to the in between R1 and R2, and the negative terminal I will connect here in between, that is small p by q here now. So R1 R2 connected here now. So we have to do short of these two, we have to do the shorted here now, and Rx is already connected here also, you have to do the shorting here now in between R3 and Rx. So based on this, first we have to check all the knobs are set at 0 or not. We have to check that one. So I will check all those things. This is 0 only. Any one person. Just hold the camera. Any one of you. See, your seniors are supporting for you peoples. Hold the camera. Yes, that's it. Live. So this is the connection diagram actually we have done here now. So positive supply, galvanometer we have connected to the in between R1 and R2, and negative we have connected to the this small P and Q, and power supply positive is connected to positive, negative is connected to the negative. R2 we have chosen this dark line, it indicates we have to do the connection. Here we have done the connection, and here we have to do the connection, and this one more path is there, we have to do the connection here. The first one, here we have done the shorted, done the connection. This one we have done the connection here now. Another one we have to choose on the R2 value here. Is it clear now?
Yes, sir.
This one digital galvanometer we have used here. This is the digital galvanometer. The value of Rx already inbuilt, it is connected here now. See here, Rx is visible here, but here the unknown resistance value we have already added inside the kit here now. I have to make sure that first it is set at 0 or not here now. So the knob is not rotating, so it is the 0. Don't consider this mark. This is 0 only now. I will set into 0 here now. So we'll switch on the supply. According to the procedure, we have to switch on the supply. Then we have to set the Rx value, someone, and we have to give the supply voltage increase. Based on that, we have to set the galvanometer. We have to make that one into 0. So I will switch on the supply now. I'll check that one. So it is indicating 0 only because there is no Rx value and even there is no supply also. There is no supply also. So I will set the 0.5. I will set. See here. 1, 2, 3, 0 to 10 points is there. Into 0.1 we have to do it. Into 0.1. So 1 into 0.1, 1. 2 into 0.1, 0.2, 0.3, 0.4, 0.5, up to 1 ohm. It is up to 1 ohm, 0.1 to 1 ohm it is there here now. So I will make 1, 2, 3, 4, 5. I will set 0.5 and actually I will give some voltages also. I will provide that. Some voltages I have provided, but see here the galvanometer is, the bridge is unbalanced now. So based on that, the galvanometer is detecting some values, it is detecting here now. Yes, by changing the value of R3, here the R3 is there, here R3 is there, these 3 knobs by varying this one, and here the R1 by this varying this 6 knob by varying this one, we have to change these values here now. We have to change the values over there. I will change the voltage also, little bit I will give. Somewhere loose collection of words. This galvanometer is very sensitive part. Something is loose connected, I think. Okay. So based on that, it is varying. So I will first what I will do. Little small value I will give here. See here. I will set the voltage value. Okay. I will change the R1, R3 value. I will change here now. Listen carefully. The R3 is, I will take into, so it is increasing. R3 increased means again the galvanometer is increasing here now. So what I have to do now, I will increase this value. Here R3, R1 value I will increase here now. So it came minus suddenly. So 1K I will increase this one. See here 89. It is reducing. 2. I'll reduce again. Again I will reduce. Again it will reduce us. What we have to make? We have to make that one into 0. Yes. So it came to 0 now. It is 0 now.
Yes, sir.
Yes, sir.
So now under this condition, we have to calculate the bridge is balanced or not. We have to do that one. I will tell the values of the R1, R2, R3. You will do the calculation here now. We'll start the calculation. What is the value of R1? I will write here now. R1, this one is 0. This one is 0. Here into 1000 is there. 1, 2, 3, 4. 4 into 1000. How much it is? 4 into 1000. 4000 plus 1, 2, 2. 2 into 100 it is
200.
R3 equal to how much it is there? This one is 0. This one is only 10 ohm. 1 into 10 it is nothing but 10 ohm is there. So Rx equal to R2 R3 divided by R1. R2 equal to how much is there? 250. R3 equal to 10 divided by 4200. Calculate it now. Not 4300. This plus 5 is there actually. 4000 R1 equal to R1 equal to 4500. We take that one. R1 equal to 4500 How much we have chosen? 1, 2, 3, 4, 5, 6 is just there, na? Okay. 1, 2, 3, 4, 5, 6. Calculate now. Can I tell the values now? Is it audible or not? All of you.
Yes, sir.
R1 equal to 4,500. R2 equal to 250 we have chosen here now. R3 equal to 10 ohm. Calculate 250 into 10. Rx equal to 250 into 10. How much it is? 2,500. Divided by 4,500. You do that one. How much you will get?
0.5.
0.5 is there?
0.55.
0.55. Okay, no problem. Plus or minus plus 0.505 is variable. See here, this is the unknown resistance is there already.
Yes, sir.
So 0.55 is the calculated value. We have to check that one. 1, 2, 3, 4, 5. 2 times it happened. So 5 into 0.1, how much it is? 5 into 0.1,
0.5.
0.5. So actual value is 0.5 and calculated value is 0.55. Is it correct?
Yes, sir.
Is it correct? So like this, we have calculated one value now. So another value will set into 0.6 now. I will set 1, 2, 3, 4, 5, 6 now. We'll set 5, 6 now. So some voltage I will increase. Based on the voltage value also it is very. Okay. So already 20 we have considered here now. So not 20. I will consider 22 now. Sorry, 12 or 11 I will consider here now. So I will vary this one first. All 10 I will vary. Here no change. This one all 10 I will vary. There is little bit decreasing here now. Here again I will change all 10. I will change that one here. So small, only small thing is changing here now. 2, 3, 4. 4 ko minus aa gaye. Next what I will do, I will decrease this one here now. Okay. It is 0 now.
Yes, sir.
0. So second rating, what we have to do? So Rx actual value is 0.6 ohm. We have already actual value we have considered. So based on this one, R1 equal to how much it is there? R1 equal to will consider. This is 0, 1, 2, 3, 4, 5, 4. 4 into 1000, that is 4,000. 4,000. 1 only. 1 into 100 is nothing but plus 1, 1, 2. Just a minute. 1, 2, 3, 4. 4,004. This is 400 plus this is 10 into 100. How much it is? This is all 10. We have increased this one. 10 into 100. Sorry, 10 into 10. That is 100 again.
100.
Plus 10 into 10, 100 plus this complete 10. So 4, 10 into, that is 10 here now. So 4,510. 4,510. R1 equal to 4,510. R2 equal to 250. R3 equal to, just a minute. Here 1 into 10. This is 0. L1 is there. L1 ohm. Now we calculate Rx equal to R2, R3 divided by R1 here. Now R2 equal to 250. R3 equal to L1 divided by 4,510. How much it is?
0.60.
How much?
0.60.
0.60.
Yes, sir.
0.60 means exactly 6 ohm. 0.6 ohm.
Yes,
Our
sir.
actual value is also 0.6 only, na? Previously it was set at
Yes, sir.
1, 2, 3, 4, 5, 6. 6 into 0.1, 0.6. Okay. So these two readings we have to write down in a table. That, so we will not further, will not take that one. Is it clear? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Just a minute. Just hold a minute. I will leave the meeting. So will you write in the table, observation table? Hello. Hello.
Yes, sir.
So that was the thing. The two readings we have taken over there. So based on those two readings, you have to take that one. You have to write in the manual. See here, how many experiments we have completed total?
4.
4 only. What are those 4 experiments? Can you tell me? Yes. First we have discussed Megger. Yes.
Yes, sir.
Yes, sir.
Megger 130 once experiment is over. Next which one? Megger के बाद कौन सा डिस्कशन किया हम? 2 wattmeter methods.
Yes, sir.
So 2 wattmeter method for the balanced load is one experiment. Unbalanced is the experiment number 3. 2 experiments are there. We have to
Yes,
write
sir.
separately. Both we
Yes.
have discussed. One for balanced load, another for the
Unbalanced. load.
unbalanced. Okay, 1, 2, 3 is over. And in the last one, we have discussed the Whitson bridge. That is the fourth one.
Yes, sir.
Now today, whatever Kelvin double bridge is the fifth one. Total 5 experiments are over. All of you be ready with the write up parts.
सर पेजेस वरती का नोटबुक करायचे सेपरेट?
कौन सा भी चलते, whatever it may be, you have to in one file you have to upload in the last.
ओके सर.
One file में upload करने के last में. Okay. So
Yes, sir.
actually this experiment also we can conduct in virtual lab. I will show in the next practical how to conduct in virtual lab. Okay.
Okay, sir.
We'll stop here only because some final year students, they are asking that TP work is going on. So we'll continue in the next class.